Well, hello there, folks. It's Friday. Yes, it's Friday today. We did the grid dip oscillator over the last 2 days, which is a bit specialist and may not be of interest to anybody, but it is another aid to tuning radios which are actually on the right frequency, because when we use this Marconi power meter, it's reading what's on the frequency, as I've said before. So when we get a new radio and it's doing 3.5 watts, if you put that onto an ordinary cheapo power meter which costs a tenner, it's going to probably read that 3.5 watts is probably going to read 5.5 watts. So it's not that our meter is reading rather tight, it's that it's reading what's actually on the frequency being transmitted, like we were doing with the grid dip oscillator. So this is the radio. This is a Realistic 2000 which was given to me by so this was kind of given me by the same person who gave me the grid dip oscillator, which is Eddy. I'm not quite sure why it was all in bits, but anyway, we changed a few capacitors in it because we got no power to the phase lock loop because of those capacitors failing. And it's pretty common knowledge that the 220 microfarad capacitors there and there really do need changing whenever you see this chassis, which is the Uniden chassis. And although it's a slightly different chassis, it's electrically the same. For the Realistic 2001, the audio line, is it 340, the small one, and the small Uniden 100 use the same chassis. Then you get the bigger footprint chassis, which is electrically the same for the Realistic 2000, which is this one, the audio line 341 is it, and then the Uniden 200. I've always felt, I'm not a lover of the Uniden chassis. I know some people really are, and I find it relatively deaf to other ones, and what I really don't like is that you can't alter the frequency of the 10.24 oscillator for the phase lock loop, and so they're never going to be as on frequency as one which you can adjust. They're always within tolerance, don't get me wrong, and I think I've only had to change crystals a couple of times in 38 years, but I like to be able to get that absolutely spot on, because it can make that difference. So we went through this yesterday with the grid dip oscillator. We tuned up the transmitter using the grid dip oscillator, and we sorted out a bit of a snag with it having a second harmonic coming out at 54, 55 megs, wherever that is. So we know we don't have to do that. We're going to have this on the power supply at 13.8 volts. I've made up a mic for it because we were just shorting out the TX line yesterday. And where did I put the mic? I actually did it in Mr. Chippy's room and used the jig we made the other day. So we'll plug that 5-pin DIN in, and you'll also notice Mr. Chippy's done redress the lead to my test equipment. 3 weeks after it's starting to grin, it finally failed. But I don't like to do these things prematurely, because that's 3 weeks extra work we've got out of it. Right, so we'll power this up. Yesterday we were at 12 volts, today we're at 13.7. So we are going to be reading different power levels to what we were then. Not quite sure why the meter's inside this, but that doesn't matter. Channel 20, Squelch looks like it works. So we know it transmits, and let's go for picture in picture. It's doing 3.7 watts. So we'll just go through some of the tuning just to make sure that when we did it with the grid dip oscillator it was right, because that was a demonstration just having a dummy load in the back and the grid dip oscillator. We'll just run through this. That's definitely peak. Definitely peak. Just check out those two at the back. Wrong one. was all right. There we go. So it's about 3.8 watts on my meter. And if you remember, we got rid of the harmonic because some of these coils have been fiddled about with. So that's sorted. So that'll do. I mean, when cold, that's going to be 4 watts. So that's neither here nor there. And that's 4 watts on this. I've done these comparisons before where we've used other meters, and there's a huge difference, especially with those Itagi ones where you put 4 watts in and they read about 12. So that's covered that. So let's see where we are with the... I'll tell you what, we'll just check the VCO because they can alter after all these years. That's the Alba. This is the realistic service manual. So it's supposed to do 3.7 watts. And if we look at that, go back to the right function, it's doing like 3.99 type of watts. So it's supposed to do 3.7. The limit spec is 3.4 to 4. So if you were, if it was 3.3, does need repairing, is what the manual's saying. So on low power, we're expecting this radio to do. We'll go for that next. It's supposed to be doing 0.4 watts. We know it's a 10 decibel attenuator. So we'll just pop it onto low power. We'll change scales on here. So full scale deflection is 3 watts. And we're getting next to nothing. I wonder why that is. Well, we'll see if we can adjust it. Sometimes it's a dirty preset. So we'll just spray that with Servicol and no, it's not going to have it. So I would suspect that the preset's got a crack in the track, and that's a function I want to work. I'll just make sure some person hasn't wired it into something else. I can't think why they would. Okay, so that's something we need to look into. Right, we'll go back to deviation. So we'll just while we've got deviation, so we'll use our little oscillator. Pop it up a fraction. See where that is. While that's spot on 2.2 with an absolute maximum of 2.5. These are always a bit bassy, and it's something I don't like. Another thing I don't like about the chassis, and I'm not, you know, we're anti-modification because it should be coming out of the factory correct. So this is one of those situations where I think sometimes a speech processor type mic like the K40 may improve matters. Not a power mic, all that does is pre-amplify. Right, so we've got that. The third harmonic, second harmonic, sorry, yes, when we were checking spurious emissions with the GDO, was minus 82. So we were at minus, sorry, is minus 72. We had minus 82. So we're well within spec. So that's something I was going to check. Current consumption, I will just tell you, is what? I think my meter's on strike. It's 1.07. I did the deviation on low power, so I'll just recheck that. Wallow. It is, it's fine. There was enough power for it to read properly because it's doing about 100 milliwatts. So on transmit on full power, we are doing 1.07, and the limit specification says it's on transmit, the current drain, yeah, I mean it says nominal it's 800 milliamps, and it mustn't exceed 1.2 amps, and so we're on 1.0, so we're just over the 1 amp. It's fine. Mind you, we've got a bit more power coming out, haven't we, than what they're expecting at 3.7 watts. Good, so that's done that. Let's see if we can set the meter, if we can even push the meter into a position. There must be a bracket missing, and we're probably going to end up with the glue gun or something, because I can't exactly write to Tandis and order a new meter. So it's supposed to be the centre of the red zone. It's spot on the centre of the red zone, which is exactly where it should be. So the RF meter is the preset just there, which is RT3. It doesn't need adjusting in this case. We can't set the frequency because the radio doesn't do that. We came to the conclusion with the grid dip oscillator, it was slightly high at, now what did I say, 27, so it being 79125, it was something like 7999 something or other. So we had it about 100 thingies off, 100 hertz off. Let's just, if I can find the camera remote, we'll just pop it onto camera 2. We'll just now check the frequency. So, there we are, 79. What happened there? 79158 we've got, and we calculated it was 79191 or something like that. So the calculation with the GDO was slightly high, and in fact it's should be 125. So it's half of what we thought was out. But nevertheless, we did calculate it was slightly high. So there we are. We can't alter that, and that's well within spec. And that is interesting that we managed to come to that conclusion. And the GDO, the Heathkit GDO, is not a laboratory instrument. You know, we're setting that up as best as we could with the frequency counter, and so that's the small error which is well within. So that's a good result. Okay, so we'll move over to receive. So we'll just dial in 2779125 on the signal generator, as you will see happening. Okay, 2779125 is near us, damn it. So the first thing we need to do is to just check on the demodulated audio. So we're going to be adjusting the detector coil, and without looking at the service manual, I would expect it's that one. So we will select this position on the camera. I'm wrong there, aren't I? It's that one then. We've gained a fraction there. So now we'll move over to the cyanide meter. And we need to adjust the signal generator, so we've got about 4 dB, which is there. Then we'll just go through the front end. The service manual might tell us what order that is. So there's a slight difference between the bigger board and the smaller board, but electrically the same. don't know why they do the receiver first, but they do. So it's 654321. They do L19, which is what I've done as a detector last, but my training is you do it first. So 654321. So we are 654321. I'll be coming back to those IF ones for a quality check. We would normally tune the opposite way around, not quite sure where they've got this idea from. Tell you what, that's pretty spot on. What I have noticed is L14, I thought was part of the receiver, is in fact part of the transmitter. We'll just go back on that. So we'll just pop the us back onto transmit. It's now doing 4.1, seeing as it's cooled down. We'll just check that's peak. There we go. Drop the attenuator fraction. I'll go through them my way, the other way around. Front end first. Just check that with a bigger signal. Check that with a smaller signal. Just take that to about 10 decibels. Just see if we can get the 20 decibel reading with very careful manipulation of these. I can't expect these to be as sensitive as some of the other sets which were contemporary at the time or even today. I say they're not as sensitive, and that's a fact. So let's see how sensitive it's supposed to be. For 10 decibel, it's got to be better than 1 microvolt, and it's blooming well better be, to be honest. So I'm just going to check that now before we... Yeah, it's about 0.95. I'm going to go through these once again, but I mustn't expect miracles because they're not as sensitive as most of the sets. Just go back to that 20 dB figure. Yeah, we can do that. Okay, I did check the RF gain and the mic gains at full, so that's where we are with that. Let's have a look at where S9 is. So I'll put 100 microvolts on, and if we can find the meter, it's just a bit low. What, about 8? So we need the RF gain preset. Sorry, it's RF gain. I'm talking about signal meter preset, which is that one. We'll just pop that onto S9 like that. So that's set. Now we'll look at the squelch. I'll tell you what, I will just go back on this detector while I'm there. That looks right. Okay, so what we're going to do is we'll start with 100 microvolts. Well, we'll start with 30 microvolts. I'll put the camera onto the attenuator of the signal generator so you can see where I am with this. So 30 and 0 is where we are. So 30 microvolts. So I want to be able to squelch that out. So I'm going to turn the squelch to full. I'll just bring this camera down towards the front a bit. So we'll turn the squelch to full. Then I'm going to advance the signal generator to 100 microvolts. I want the signal to now be received. So we now need to adjust the squelch preset RT2 until that comes in. If it ever does. And it doesn't. Okay, so the set can't achieve what I want. So we need to now see where it really is. So the best I can squelch out is 800. Sorry, is 80. So we'll go to the other end and see whether it's any good. So we'll switch the signal generator off, turn the squelch to threshold, switch the signal generator on. Let's see where we are now. It's 1.5 microvolts to open, 1.4 to shut off. So not very sensitive. Just to give it a second chance, I'll reset the squelch again, but with more care. Okay, we've got that set really carefully on threshold. Switch the signal generator on. .1 coming in, 1.7 going out. Yeah. As I say, people swear by these, and I think the realistic version is the best of the three. But there you are. I say they don't impress me that much, but you know, they are well-loved sets. So you know what? I think we've covered everything now. I just need to do a few remedial things to we'll sort that 0.4 watts out. I'll go for a lunch break, and we'll do that preset on the way back. One of the things I have done is to change the two audio capacitors just there. They're both 470 microfarads. One's supposed to be 10 volts, the other's supposed to be 16. but we don't bother stocking 10 volts, and so I've replaced them both with 16s. So let's see what's come out, because it did sound a bit thin, the audio. I've also put the lids through the dishwasher. I'll just do that again because it's quite possible that I had the leads shorting out. I haven't got the leads shorting out this time. Let's try third time lucky. Yeah, that's better. I had got some shorting out. So that was alright, but in the bin it goes. Now these are 38 years old, and you know, other capacitors have failed. Yeah, that was yeah, definitely wanted to go. So that's the 10 volt one, needed replacing. But we replaced them both. They're only about 12 pence each anyway. Right, the other thing I've done, we've kind of put the front back on, and I've had to glue the meter in. It's the wrong kind of meter, and so that's why the previous person had the front off it, because this meter doesn't fit it electrically. As you know, we tuned it up, and the meter read spot on. We were able to adjust that, but in actual fact there's a chassis cross member which stops that type of meter going in. Now, this is a scrap set, remember that. This isn't somebody's pride and joy. And that meter electrically works. So the answer was, get a junior hacksaw blade to the cross member and cut it out. Job done. Now the meter's in position and it fits the bezel. What a bodge. So, just on the final bit of this now. I've put the bottom lid on because we're going to just check the receive once again, because there can be a capacitive effect, that's a good word for Friday, with the lid not being on. So we'll just look into that. Okay, so it's all back together, and I've just done a quick check to make sure there's nothing. Here's a scrap of paper because I can't be bothered to go and get a real one, and we'll just look at the cyanide. Now it's finished, shall we say. 20 dB cyanide, 12 dB cyanide, and 10 dB cyanide. So just switch the picture-in-picture on, and we'll look at the cyanide meter. Okay, just to do that, yes, things have improved dramatically. I've had to link out the RF gain control. The controls best described as knackered, so it's better to not have that than to have a radio that's not performing properly. So some of its deafness was down to that. So 20 decibel, it is 1.1 microvolt for 20 decibel cyanide. We'll now look at 12 decibels. Are we on the next scale? No, we're not. So for 12 decibels, it's now doing 0.35 microvolts, which is fantastic. So before we'd got 0.7, but it was this RF gain control which was playing up. Of course, there's no chance of getting a concentric control. You know, this is it. This is a scrap set, and you know, sometimes you've just got to do these things to make it work. And 0.31 microvolts. So if we compare that to the manufacturer's info, they said better than 0.5 microvolts for 10 decibel cyanide, and we've got 0.31. So the limit spec was 1 microvolts, and we were about 0.7 before I sorted that RF gain control out. So there we go. Set's working nicely. Hopefully we've also improved the minimum squelch. I'll just check that. Yeah. Coming in at 0.29 microvolts, going on at 0.2. That's excellent. So bridging out the RF gain control, it was just a matter of shifting the blue wire to the earth on the other control. So that is now ineffective. So we've glued the meter in, that's bodge number 1. We've bypassed the RF gain control, that's bodge number 2. And we put a brand new preset in there. It's 470 ohms, though it shows 1K in the manual, but I put 470 ohms in. And just to show you that, we'll just go back to there, hopefully. Camera 2, there we are. And if I key up, in low power mode, we've now got 0.4 of a watt. There's 0.5, there's 0.4. And then on full power, we've changed scales, and we've got, well, about 4.2 at the moment. It's nice and cold. So there you go. We'll just pop it on the aerial, put that lid on it. I did check the speaker whilst I was putting it through the dishwasher. Is that the right one? Oh, don't know now. No, it's that one I definitely put through the dishwasher. So we'll just solder that back on, and we'll just test it on the aerial. Okay, so we've now got it on an aerial, and $19 a Roger. No, they won't hear me above the burners. Oh, somebody's out there on channel 40. Okay, we'll take that up to 31. And usually the control panels on these are a lot worse condition. So this is the second time I've had to link out an RF gain control on one of these. With these concentric controls, there's just no chance now they're 38 years old. Support stopped 7 years after they were made, so 31 years after the support stopped, that is the end of it. Special things like this are the killer on a lot of products, not just with CB radios. I mean, things like the volume controls we can usually change, but because they're a pretty standard item. But you know, it's the same with the slide switches. You can get replacement slide switches, but they're not going to have the same inserts on them, you know, so that then it's spoilt. So at least it's all displays working, transmit lights working. So you know, we've made something out of a scrap radio there, and I think that's worth doing. And parts cost wise, well, it's probably only cost £1 to do it, you know. So it's just taken a lot of time. So there we have it, the realistic TRC2000 resurrected from a scrap bin, and now with no RF gain control that works. So we're going to do a test right now, so thank you for watching.